Hi, welcome to the WTAMU Virtual Math Lab. This video will step you through College Algebra Tutorial 15, Example 3. In this example, we want to solve the equation 3 over x minus 3 equals x over x minus 3 minus 3 over 2 for x. The goal here is to get x by itself on one side and everything else on the other using inverse operations. When we do the inverse operations, we want to make sure that we do the same thing to both sides in order to keep the two sides of the equation equal to each other. In step 1, we want to simplify the equation by removing the fractions. We can do this by multiplying by the least common denominator, or LCD. The factors of our denominators are x minus 3 and 2. So our least common denominator is going to be 2 times x minus 3. Let's see what it looks like when we multiply both sides by 2 times x minus 3. On the left side, we have 2 times x minus 3 times 3 over x minus 3. On the right side, we'll have 2 times x minus 3 times x over x minus 3 minus 3 over 2. On the left side, the x minus 3's cancel, and we're left with 2 times 3, which is 6, equals, on the right side, when you distribute the 2 times x minus 3, you get 2x minus 3 times x minus 3. In step 2, we want to solve the remaining equation. We can remove that parenthesis by using the distributive property. So when we do this, we will end up with 6 equals 2x minus 3x plus 9. Combining the like terms of 2x minus 3x, we get 6 equals a negative x plus 9. It looks like we have the constant term of 9 to move. The inverse of plus 9 is to subtract 9 from both sides. So we're going to end up with 6 minus 9 equals negative x plus 9 minus 9. On the left side, we'll end up with a negative 3, and on the right side, the 9's cancel, and we're left with a negative x. The inverse of multiplying the x by negative 1 is to divide both sides by negative 1. When we do this, we get negative 3 divided by negative 1 equals negative x divided by negative 1. This leaves us with 3 equals x. In step 3, we want to check for extraneous solutions. For rational equations, extraneous solutions are values that cause any denominator in the original problem to be 0. Of course, when we have 0 in the denominator, we have an expression that is undefined. So we would have to throw out any values that would cause the denominator to be 0. Note that 3 does cause the denominator of x minus 3 to be 0, so it is an extraneous solution and we will have to throw it out. So our final answer is no solution.